Non-repudiation, the last security goal of cryptography that we in this course will have a closer look at, is the security goal demanding that in a system with non-repudiation, the source of information can be verified by any third party. As such, non-repudiation is a stronger security notion than authenticity, as the third party is now not necessarily a party involved in the online interactive exchange of information, as it was the case with authenticity. The main cryptographic concept serving the security goal of non-repudiation are digital signature systems. Digital signature systems are systems where the state of information is captured in a digital signature that is then attached to the information. These digital signatures are calculated based on the private digital signature creation key of a participant in such a system. Once such a digital signature for a plaintext is created based on the private digital signature creation key of a participant, then this digital signature can be verified by using the public digital signature verification key corresponding to the private key, which verifies that the digital signature matches the plaintext and that the digital signature was created with the corresponding private key. As such, it's clear that the source of information can be verified to be the participant in possession of the private key, and that this can be verified by any arbitrary third-party entity and not just an interacting recipient of the information. Peeking briefly under the hood of digital signatures, a digital signature is often just a hash of the plaintext encrypted with the private key of the participant, and verifying a digital signature amounts to decrypting this encrypted hash with the public key corresponding to the private key and comparing the decrypted hash with a recalculated hash of the received plaintext. If a cryptographic hash function is used to hash the plaintext, then digital signatures can bind the signature to the plaintext down to each and every single bit. There are a couple of different types of digital signature systems. One major type of digital signature system relies on the asymmetric encryption of the cryptographic hash values with RSA, and the current recommendation is to use the probabilistic RSA digital signature scheme, RSA PSS, which introduces randomness into the creation of the digital signatures, which is required to really provide security to the digital signatures created. Another major type of digital signatures is the digital signature algorithm DSA, which results in digital signatures not based on RSA, but based on the discrete logarithm problem. DSA has been a NIST standard since 1991, but has a strong requirement on a very high-quality source of randomness, which may prove challenging or impossible for systems to provide, and as such, DSA is currently suggested for delisting as an approved digital signature scheme. An elliptic curve variation of DSA-based digital signatures, or ECDSA digital signatures, which enjoy some speed and key length gains over DSA, but essentially have the same security challenge as DSA digital signatures, and as such are likely soon delisted as an approved digital signature scheme as well. In order to not have the security challenge around high-quality randomness, the by now popular ED-DSA type of deterministic digital signatures has been developed, which are elliptic curve-based digital signatures, with the two most popular implementations now being ED 25519 or ED 448. This presentation of digital signature types now concludes the presentation of the essentials of cryptography for this course. With this, we are all set to understand the cryptographic mechanisms taking place within TLS, so let's get finally started with looking at this amazing cryptographic protocol that TLS is.